here. So at the rate column, nullable as false, private big decimal search factor. Now this is big decimal, so it makes sense to define precision here. So let's just make precision as 2 or 3 or whatever, and then you can define the scale as 2, like so. So this would mean that we can only have 99 times of the search factor. I think it's good enough for us. Maybe we can make it 5 here, right? So that means we can increase the price up to 1000, 10,000, 1 lakh, right? And then we can have two digits after the decimal. So that is the search factor for us. What do we have next? We have the actual price. So I'm going to store the price as well for this particular date for our room. I'm going to store the price here only. So at the rate column, nullable as false. Again, we need the precision for the price. I'm going to keep it at 10 and the scale is 2. Private big decimal price. So price of the inventory can change every day. Here you can see, that's why we are keeping a price here. And to calculate the price, you have the search factor, and the base price is already stored inside your room type, right? So using that room type information and using the search factor information, we can simply calculate the price. It would be equal to base price multiplied by the search factor. And then on top of this, we can update the price furthermore using our dynamic pricing model that I have talked about in the last class. So now we have the city and the closed information. So at the rate column, nullable as false, private string city. I'm going to store the city information here only, as I mentioned in the beginning of the class while defining the schema. It's better to put the city information here because we are going to search on the basis of city as well, right? For an inventory, we are going to search on the basis of city. So by putting this information here, we are not making a join query to the hotel rooms, and that's going to save a lot of time. So this right here, I am denormalizing my database like this, because this city field is not going to get changed that frequently inside my original table. And if it is changing inside my original table, maybe some user wants to update the city of the room hotel. If they do that, then we can handle that manually, but that's not going to get changed that frequently, and it's going to save a lot inside our queries. So that's why we are putting the city here. All right, so what else do we have? The closed. So at the rate column, private boolean closed. So this is the field that admin can set on a particular date. They can say that, yeah, this particular room is not available on this particular date for booking. So that way they can put a closed field on any day, and then we won't be showing this particular inventory on those days. And then we have the timestamp. So let me just copy the timestamp field from here only and paste that there. So that's how we have created our inventory, and I've added the unique constraint here for these three things. These three things have to be unique, like the tuple for these three things, you can understand, has to be unique. Tuple or the combination of these three things have to be unique. After this, we can specify some more things. I have created the inventory. It's time to create the booking. So let's create the booking now. So entity, new Java class booking at the rate entity. Let me just copy it from here. Like so, and we can remove it from here. The name booking is good enough for us, and then we can start adding the ID generated value, The strategy is going to be identity, private long ID, like so. And then inside the booking, we are going to have fields like ID and the room, because each booking will belong to a particular hotel room and a particular room type, right? So it has to have those things, and those things are also there inside the inventory. So I'm just going to copy these things from here. So just copy it and put it here, because each booking has to have a hotel ID and a room ID, right? So I'm just going to put these things here. And then we also have the user ID. So each room booking belongs to a user. We have not yet created a user. Let me just see. Yeah, booking belongs to a user ID. I have to create a user for that first. Yeah, let me just do that. Let me create a user first, and then let's create the booking. All right. So I'm going to create a user first, and then let's put these fields here. Let's create the ID for the user, ID at the rate generated value. Strategy is going to be of type identity, private long ID. So now we have the user ID, and then each user is going to have a email. So column, and the unique has to be true. So we have added a unique constraint at the column level only. So this column has to be unique for each user, and then it has to be nullable false. So it is required. It is required, and it is required to be unique. So when you create something unique now, PostgreSQL is going to automatically create an index for it. So you don't even have to create an index on the basis of email. So if you are searching on the basis of email, that search query is going to be very fast. Okay, so now we have the email, and then for each email I'm going to store the password as well. I'm going to store password here only inside the user, and then we'll understand later on that how we're going to store this password. We're not going to store the password as plain text. No, this is not recommended. We are actually going to encode it. So we're going to encode it, and then we're going to store the encoded password inside a database. We'll learn how to use a bcrypt password encoder when we get to a Spring Security. Right now, let's just make this field nullable as false. So we have the email password. Let's also put the name here, string name. So we can get the name of the user when we are creating a user account. We can make it nullable as false, nullable as true here, because when a user is being created, sometimes in the user flow we don't know about the name yet, right? So that's there. Alright, so we have the user entity right here, and as I mentioned that we are also going to store an array of roles here. So for that I'm going to create an enum right here. So for enums I like to create another package, and I'm going to put all my enums here only. So for the user role, this is going to be the enum, public enum role, and the roles here each user can have is guest. So each user will have a guest role. Whenever we create a user, they will have a role of guest by default, and then we can also add a role of hotel manager by ourselves. So this particular role we can specify to some users, and then they can only perform certain operations because they have the hotel manager role. So I'm going to put this enum inside the user. I hope this is not getting very complicated, guys. Let me just know. Number of rooms. Why room to inventory has one too many to one? Let me just look at the doubts here, because I think there are 2-3 questions coming in. Where are we connecting hotel to a room? So let's see. There is room, right? There is a room, and in here are you able to hear this noise in the background or no? Like what? Yes. I don't know. There are some monkeys right out of my room. No, these are not murgas. These are monkeys right out of my room. They are fighting or something. This late in the night. It is scary. Scary for me as well. This is the first time in the night they are doing this. Ah, where were we? Why room to inventory has a mandate? Yeah. So someone was asking where is the connection from room to hotel. So there is the connection from the room to hotel, right? Will have room entities inside the table, room entries inside the table of room, and then in there we'll connect each room to a particular hotel ID, right? So as soon as you create a room, you connect it to a hotel with this particular field. So that doubt is solved. Another was number of rooms, and if user chooses two different rooms in the same booking ID, yeah, user can do that, and I don't think I have specified that. So that is mm, yeah, that is a great catch, that we have to add the number of rooms inside a booking, because in each booking we can have multiple number of rooms. So that is something that I'm going to put here only. So thanks for that. I don't think I have put that here, so let me just put that here as well. Check in date, check out date. Yeah, we have not put the uh, number of rooms here, or the rooms count. Rooms count of type integer. So in each booking you can define like what is your room type with the help of this room ID, and you can specify the rooms count that you are going to need in this booking, and accordingly your price is going to get generated for that particular booking. That's a great catch. Why room to inventory has many to one mapping? Room to inventory, where is it? This is the room. There is a many to one mapping right here. So by this what we mean is that many inventories can belong to a particular room. All right. So by that what we mean is that let's just come here. This is the inventory and this is room, right? So many inventories can belong to a particular room because this room can have inventory on different days, right? One room will have inventory on different days. Inventory is going to store the information about a room on different days. All right. So one room will have entries about of that particular room inside the inventory on different days, and that's why we have this many to one relationship from inventory to the room. So what's going to happen is, inside the inventory table you will see that for a particular room ID, let's say you have a room ID of 5. For a particular room ID 5, you will have multiple fields for room ID 5 on different days, right? So room ID 5 day 1, room ID 5 day 2, room ID 5 day 3, and so on. All right. So that's why this mapping. I hope that is making sense. Voice is breaking. I hope it is not breaking for all of you. Let me know. I complete 1 unit lecture until I'm able to understand everything. That's really great, Gautam. They also want to join the class. I don't know why they are doing this. They also did it a few minutes back. We are not mentioning one-to-many mapping anywhere. One-to-many mapping. Yeah, one-to-many mapping, you want to mention that when you are owning the relationship inside some table here only. For example, here we have inventory, right? If you want to store the information about the inventory inside the rooms only, then you would put a one-to-many mapping here. But that is something that I'm not going to do, right? We don't need it. We don't need the information about the inventory of each day by looking at the room, right? And that's why there is no one-to-many mapping. There are many to one mapping, but there is no one-to-many mapping because I don't want to look at the information about each inventory for a particular room. For that, I'm just going to go to my inventory table and I'm going to query it from there. But like if that is a use case, if you want to query from a particular room, then you can do that. What all you have to do is just put a one-to-many mapping and then list of that particular entity, and then you have a one-to-many mapping. All right. Any other questions? All good? All right, let's continue now. So we were at the user, and now we have added roles inside the user. So what I'm going to do is I'm going to put these roles inside the user as a set. So private set of roles, and also this would be of type enumerated. Inside enumerated we can define the type as string. So we are storing actual string values of the roles and not the IDs of the role, for example 1 2. So what happens is that if we do this ordinal now, so we have two options, we can make it string or the ordinal. If we do it ordinal, what's going to happen is that for each user we'll have roles like 1 or 2, because we only have two roles. So this would get ID of 1, this would get ID of 2. Then by looking at the table you won't be able to know like which role is it. So it's better to make it a string so that we are storing the roles as string. So by looking at the table we can know like which role we are talking about. One more thing, if we are storing like a string or the array, then we have to make it element collection, so that we JPA is going to create another table for us. So element collection like this, and then we can specify the fetch type here as well. Fetch type is eager here. Let's see. So it is lazy by default here. We'll have to make it eager so that we are fetching the roles every time we are getting the user ID. One more thing, it's a peculiar thing about PostgreSQL database, because PostgreSQL uses something called user table. Internally they use user table. So if you try to create user like this, then you are going to get an error that they will say that hey, you cannot create a table called user. So for that, can anyone suggest what do we do? If PostgreSQL is not going to allow us to create a table called user, then what should we do? Tell me. Someone says table annotation. Manik says if there is one-to-many relationship between hotel to a room, can we see how many rooms available in that hotel? Yeah, you can do that easily, right? Because we have already added a many-to-one relationship over here, right? This is the many-to-one relationship. All you have to do is just do this. Let me just show you. Private list or set, whatever, list of rooms, right? And then you can do one-to-many, and then you can define the mapped by query here. Mapped by which field? So just go to your room, mapped by the field over here, this hotel, right? So just define this field, and now this is the connection. You just click on this and you are here, right? So there is a direct connection. So now just go to a hotel. If you want to fetch all the rooms of that hotel, just go to the hotel and do hotel.rooms, and it's going to fetch that. But the thing is, now it's going to every time you query your hotel, it's going to preemptively find the hotel rooms as well. So you'll have to make the fetch as lazy, so that you are not doing additional computations. So if you are doing that, then it makes more sense to remove it from here and then just query your rooms on the basis of a hotel ID, and then you would be able to get all the rooms belonging to a particular hotel. Like both these things are good, you can do it anyway. Hope that is making sense. Change the name, user table, yeah, those are great ideas, guys. Because we cannot create username, then we'll have to define our own name, and I can just name it anything, name app user or something. So this would be app user, right? We have ID, email, name, and roles, all these things. And then we have this new thing, element collection. What this is going to do is going to create another table for us, which is going to be of name app user roles. All right, app user roles, and in that table you will be storing all the roles a user can have. So a one-to-many mapping would be happening over there with the help of this annotation. So we learned about two new annotations, I guess, in today's class, right? Element collection, enumerated, and one more, which was the it's just slipping my mind. Which annotation was that? Yeah, embedded and embeddable. Yeah, this one, right? So we learn about these annotations. Great stuff. So now we have a booking, right? Each booking will belong to one user. So I can have user like this. So a user can have many bookings. So think whenever you're thinking about one-to-many or many-to-one relationship, think like this, that each user can have many bookings. All right. So many on the part of booking, that means it's going to be a many-to-one like that. And then whenever we are fetching the booking, are we going to fetch the user as well? If that is the case, then define the fetch type as lazy like this. At the rate join column, we can define name, user ID, nullable as false because each booking has to have a user ID, and then private user like this. So many-to-one relationship like this. All right. What else do we put inside booking? Someone mentioned that we have to put the number of rooms. So yeah, that is great. I'll put that here. Private integer rooms count like this. Check-in date and checkout date is important. So private local date check-in date, and similarly we have checkout date. And then we need the created at and updated at timestamps. So let me just copy those from somewhere. So yeah, this is it. Let's define the rooms count here. This would be column. Defining a column definition is something that is optional for you, but I feel like when you are designing a schema, you should do it at that time only. For example, this would be nullable false because you are creating a booking. You have to define your rooms count. Like in this booking, how many rooms are you going to have? So this thing is important for a booking. So that's why this room count is going to have nullable false. Similarly, check-in date and checkout date, these things are also nullable as false. Excuse me. Check-in date, checkout date. We are also going to have payment ID. So for that, we'll create a payment object. And we are also going to have guests information here. So I'll add those later on. Copy this, put it here. Yeah. So we'll have to add the information about the guests and also the payment information. So let's do that now. Let's first create the payment info. Payment at the rate ID at the rate generated value strategy of type identity private long ID. And then in each payment we'll have a transaction ID as well. So private string transaction ID. This will be unique and This would be unique, but let's see, we have created an object and then we'll go to the transaction page and then we'll get the transaction ID from there. So we won't get transaction ID right away, or we will get the transaction ID right away, but then we can have a webhook up there. So let's just make nullable as false this one as well. And then we'll have information about the price and all. So let me just put those, and also the status. So for each payment we can have payment status. Payment status, this would be enum. Payment status would be pending first of all, and then this would be confirmed, or this would be cancelled, like this. So private payment status, this would be enumerated with type string, and then we can define the column definition as well, that this is nullable as false. And then the amount, private big decimal amount at the rate column, nullable as false, and the scale and precision. So first define the precision as 10 and the scale as 2. So we have connected it with the transaction ID. We have the ID, amount, all these things. We are not going to connect the payment with the booking because we are connecting booking to the payment. All right. So let me just connect the booking to the payment. At the rate, each booking has to have one only, so 1-to-1 mapping. And then we can define the fetch as eager. Eager is there. So let's make it lazy. Private payment, like this. And then as I mentioned that we are going to have guests as well, right? So for that we are going to add entity called guest. Let me just look at the guest entity. So we have the payment. I've created all these things, status and all these. In booking also we should have a status, right? I have not put a status here in the booking. Yeah, there is no status here, so how come? So let's put it here as well. Booking status, this would be enum so booking would be reserved or pending, both are the same, reserved, and then confirmed or cancelled. All right, these three status would be there. So we'll have to have a booking status. So at the rate enumerated of type string, private this was booking status. All right, so we have the booking status over here, and then we can define the column definition here. So let me just copy this, copy this, put it here, and also put it here. Oh yeah, here we have to define join column only, like this, because this is going to create a column here. So I can also put payment ID here. So name would be payment ID. So this is the column that we're going to store inside the booking. So in each booking they'll have a payment object like this. All right, nullable as false. Yeah, this should not be here because nullable, it should be nullable, right? Because in the beginning there will not be any object called payment. When we are making a booking, whenever we are reserving a booking, we are not yet on the payments page, so how can there be a payment object? Okay, so we have the payment and the booking, and now we are good to go. Let's make the guest. So a user can have multiple guests like this, right? So we have user ID here and the name and also the gender. So let me create an enum first for the gender. This would be male, female, other, and then we can create guest. This would be entity, getter and setter. ID of generated value of strategy, identity, private long ID. So each guest is going to have an ID and they are going to get connected to the user. So they will have a @ many to one. Actually, I'll probably add one to many relationships. I'll probably add some more one to many relationships because I don't want to create more repository methods or JPA methods just to get all the guests related to a user. So I'll probably do that in the future. When we are going to create the APIs now, I will probably add those one to many relationships then, because one to many relationships are not going to get stored inside the database. That's something that you need to understand. Only many to one relationships, because here we have the what do you call it, we are owning the relationship here inside the guest, right? And we are not creating another table for it. So we are storing all the information here inside the guest about the user. So we'll have a new column inside the guest which will be user ID. So it's not going to affect our database in any way. It's just that it's more convenient for us, right? So many to one relationship here, private user, and then we can have join column information here that the name is going to be, let's say, user ID, like this, right? So by that we mean that one user can have many guests, right? What else do we have? Each guest has to have a name. So private, and then they'll have a gender. So @enumerated, private, gender. We can also get the information about the age, private integer age. We can make it nullable as false if we want. And then the created @ and updated @ those fields would be there. Each user is going to have some bookings. I mean, each guest belongs to some bookings, but again, that's something that we can easily query from looking at the bookings, because booking is something that's going to own this relationship. So this information is enough. Sometimes they also ask for email and phone numbers and stuff, so you can add that if you want. I'm just going to leave these things here, and then I'm going to put the guest information inside my booking. So there will be a many to many relationship, many to many relationship over here from my booking to my this guest, right? Because one booking can contain many guests and one guest can belong to multiple bookings, right? So that's why they'll have a many to many relationship. And can anyone tell me how to have a many to many relationship in Spring Boot? Like, how can I do that? How can I have a many to many relationship? what comes to mind? These enums will be stored in DB as multi-valued attributes. So basically, when you define something as enums, what this PostgreSQL is going to do is going to say that this booking status will have the values that can be only be of type of this, that can only have values like these three things. So when you define something as enum and when you put this enumerated, you actually put a constraint on this particular column that this column can only have values defined over here, reserved, confirmed or cancelled. So that is something that's going to happen. All right. The question was answered by Abhishek Kumar Prasad. That's really great. Yeah, join table. The question was, how am I going to have many-to-many relationship? How can we facilitate a many-to-many relationship in our Spring Boot application? So that's going to happen via the join column or join table, because in join column we cannot have that, right? So for that, a new table altogether is going to get generated, which is this table. Actually, you can look at this table. This is the booking guest table. I don't have to create this table myself. Spring Boot will do that on my behalf, because I'm going to create a many-to-many relationship between guest to the booking. All right. So here you can see this is many right here and this is many right here, and this is a join table. So this is a many-to-many relationship between booking to guest. So this table is going to get automatically generated for me. So let's do that. And we can actually, let me just put this first, private set of guests, and we can actually configure our join table here. So someone was saying that he was not able to understand join table. I hope they are able to understand from here that we can create our own join tables here. For example, this would be called booking guest, right? This is the join table. And then in here we can define the join columns, and then we can also define the inverse join columns, right? These two things, these are the most important fields over here. So let me just define those. So this is the join table, and then here we can define the join columns. This would be defined like this: join columns, like join column, this one in here, because this would be related to only one column, right? This would be my booking ID, this one, right? This is the booking ID. So I would name it my booking ID. This is the name of my join column. We have to make it name. And then we also have reverse in, wait a second, inverse join columns equals to @join column, name would be guest ID. You can skip this altogether, like even if you don't define this and even if you don't do any of it, Spring Boot automatically is going to create a table for you, and they will name it like this only, I think, booking guests, because this table is called booking. So they will name it like this, booking underscore and guests, like that. So they will also add this S because you have added this guest here, and then they will create two tables for you. One would be called booking because this table is called booking. I think they will also add the ID, and they will create another column which would be called guest ID. So basically this table would be created which will have booking ID and the guest ID, and they will automatically create a table called ID for you. So we can ignore all these things, or maybe we can configure all these things by ourselves. So that's how you have a many-to-many relationship between guests to booking. So if you are on a particular booking and you want to look at all the guests in that booking, so just go to that booking and do .guest, and you would be able to find all the information. We can define the fetch type here as the lazy. So when we do .guests, only then we will be able to see all the information about the guests. One more thing that we can do is we can come here inside the guest, and we can do a many-to-many mapping here as well, and then we won't be defining a join table. Don't define join table at both places, guys. That is something I want to say. Don't define join table at both the places. If you have a use case like this, that inside the guest, by looking at a guest you want to get all the bookings of that guest, you can do that easily. All you have to do is just come here, you have to define a many-to-many relationship and do this private set of bookings. That's it. Now do not define a join table again. Can anyone tell me what would happen I define a join table again? What would happen if I define a join table again? Here, if I create a join table again, what would happen? What do you think would happen? Exception creates a new table. Yeah, that's exactly what's going to happen. It's going to create another join table, which is not required, right? So don't create another join table. And if you have the same join table name, it's going to throw an exception that you are trying to create another table with the same name. Cannot happen. So only put one like join table and join column, these information should only be present at that place which is going to own that relationship. You want to join two things, one has to be the owner of that relationship, so put the information about the join column or the join table in that entity which is going to own the relationship. I hope that is making sense. All right, so here for example join column is here, right? This is the join column. That means this guest entity is going to own this relationship. So even if you have a one-to-many mapping inside user, from user to guest, you are not going to put a join column over there. All right, I mean that will not work there, but yeah, you won't put put it there. So yeah, I hope that is making sense. So we can have a bookings like this, and it's not going to create any table, it's going to use the previous table that has been created. You will have to define the mapped by field here though, this mapped by field. So this would be mapped by this particular field, the guests field over here, right? So this would be mapped by guests like this, and now you can just click on this and you can come here. So this is how you have connected these two things. But I don't think we will ever have a use case that we want to look at all the bookings of the guest. Like I am here, I have 5 guests in my profile and I want to go to a particular guest and I want to see in which booking this guest has been with me. So I don't think that will ever be a use case, so you can just remove it from here. All right, just side note. So let's just come back to booking. We have the guest information here, we are owning the relationship over here. We have this booking table, that is all great. See, we have guest. Yeah, I think we are done with all the relationships now, right? All the entities are here now. Let me know if I have missed something, guys, if you feel like I have missed some entities or some fields. According to my knowledge, I think I have added all the fields that were here. Status, all these things, gender is here, closed is here, rooms count. Yeah, cool. So after this, let's run this application and see if we are able to get all these tables created inside our database. So let's run this, enable annotation processing. So yeah, here you can see these are all the Hibernate queries that got generated for us, right? These are the queries. And why are these queries getting printed over here? Because we have added a particular console, we have added a particular property over here inside the application properties, which is this one, Spring JPA show SQL. So here we are saying that show SQL every time, right? So and also the DDL auto is set to create. That means it's going to drop the table first and it's going to create another table, right? So that's why it's first trying to delete everything. Here you can see drop the constraint, drop the table, drop the constraint, drop the table if it exists, right? And then it's dropping the table if it exists, because we have set it as create. If we have made it update, it won't drop the table. All right. So after dropping everything, now you can see we have created a table called app user. So let's just visit everything again one by one. Come here, app user. So this is the table name, app user. All right. It has fields like email and password. So just look closely, because this is going to be very interesting and a very nice thing to learn, that all the things that we have written over here are getting mapped as SQL queries. For example, for this email, just look at this email field. This is a varchar of 255. Why? Because this is of type string. Not null. Why? Because we have made here unique as true, and nullable as false, and that's why it is, oh, sorry, not nullable, I mean that is why this is not null, and unique is here because this unique is true, right? So that means it is going to be a unique field inside the database only. And then we have the name field over here, name field, and then we have the password. Where is the roles? Oh yeah, roles is going to have another table altogether. So for roles, you will see that roles is not visible over here because roles will have another table which is called app user roles. It should be there somewhere. Let me just find that first, and then we'll move on. Yeah, user roles. This is the table, right? So here we can see this is the table. Inside here we have the user ID, and then we have the role. A role is something that is getting checked by a Spring Boot, that check if the role is in guest or the hotel manager. So even if you try to put another kind of role like super admin or something, it's not going to get added inside the table only, because the PostgreSQL database is going to discard that query. So even if you try to add that query, try to run that query, try to hardcode that some role, it's not going to get generated because we have set it as this. So someone was asking me like, why are we adding enumerated, or is it going to get stored somewhere? I hope that doubt is now getting resolved, that when you do something as enumerated, it's going to add a particular constraint or check that, hey, do not add anything else, only put these fields. I hope that is making sense. All right. Okay, so we have looked at the user. Let's look at the booking now. So this is the booking. So it's creating a table called booking. That's great. We have a check-in date of type date, which is not null, not null, not null. Rooms count is here. Created at is of type timestamp. Hotel ID is here, which is of type big integer and not null. And the ID itself generated by default as identity. So this is here because we have put it like this, ID as this. The payment ID is here. The room ID is here. Updated at user ID is here. Booking status is here, and says that booking status can only be reserved or confirmed or cancelled. And the primary key would be this ID field, the ID field that is defined over here. So that is the primary key for this particular table. We have to define a primary key, and this is getting defined by using this annotation over here. And then we have this booking guest. Now this booking guest got generated. We didn't do anything because we have defined something over here, this thing. So this is the booking guest, right? Booking guest over here, and it has fields like booking ID because we have defined booking ID over here, and the guest ID, and the primary key would be defined by combining these two things. All right. So primary key is a combination of these two things now. Then we have guests information. All these things are now pretty easy to understand, but yeah, we have the hotel information over here. Here you can see this is of type text array, so we can easily create text array, and we have added this definition, column definition, because this type was not there by default inside the JPA, but since our underlying database supports this column definition, so we can easily add this column definition. So this is of type text array now. I had also added this column definition somewhere, I remember, just to show you that we can add column definition. Let me just search. Yeah, this one. This was inside inventory. So let me just look at that, what happened to this one. So this was about the booked count. So let's look at that booked count field inside the inventory. Yeah, this one. You can see this is of type integer, default is 0, right? So here we have set the default to 0 at the database level only, and then we have made it not null by making this nullable as false. So this is how you can change your column definition. Integer is here small case, while this is uppercase. I don't think it should be any issue, but yeah, I mean, if it were an issue, then we would have gotten an error. The price here inside the big decimal is going to get stored like this. So we have field called numeric inside PostgreSQL database. we defined like how long it can be, and what is the decimal, after decimal how many digits can we have. So this is how we define it, and our JPA is converting our definition to this, right? So the precision and scale is going to get converted like this. Created at, updated at, hotel ID, all these fields are here. And then constraint on unique hotel room date. So this is the constraint that we have added. Actually, you can see this is the unique key constraint that we have added, right? So we have added the constraint over hotel ID, the room ID, and the date. So that constraint is getting printed over here. Then we have added payment, the room is here, it also has text array, user roles, I've already seen that. Yeah, and then we are altering the table, we are adding some constraints here. So we are actually adding some foreign key constraints like this, that inside our booking we can have foreign key called hotel ID, right? So all those constraints are now getting here. For example, inside booking we can also have foreign key to payment ID, it references payment. So all these things, we don't have to do any of these things because JPA is going to do that on our behalf. I've seen that in some companies they use JPA, in some companies they don't even use JPA, they use other tools like Flyway, and then they create their own queries, create queries by themselves. Have you seen that happen? What about foreign key? Got it? Got it. Have you seen that happen, that they use some other tool like Flyway? There are multiple other tools as well. I just can't remember the name right now. But yeah, those tools are used for database migrations as well and managing your database versions. So they have database administrators, and you tell them that, hey, I want this particular type of schema in my database, then they would create that schema for you. All right, they would create that table for you inside the database, and then only you can start working on your project. So that is the first requirement that you have to do. In mostly big companies and banking kind of companies, they do that because they are very particular about their database there. So they don't allow their developers to work with their database. Golden Gate, what is that? Yeah, could be that tool. I have not heard about that tool. Why we need map by? It's automatically map it my IDs. Mapped by will tell it like how do you want to map it to a particular field inside your Java code, because that field is going to get mapped automatically inside PostgreSQL. That is great. That is great. But how will our code know like how to map it, right? Our code or Java class will not know. So that's why we need that mapped by. So where is it? Map. Where was it? Mapped by. I have added it somewhere. Oh, that constraint is there somewhere, but mapped by is there so that you know how to map the entity back, because your Java has to know everything. So if you are owning certain relationship, you don't need mapped by, right? Because that's going to automatically get mapped. But if you don't own the relationship, then you have to have something to connect to the table, right? Because you don't even own the relationship and you have no way to connect to your table. So that's where your mapped by comes into the picture. I hope that is making sense. Yeah, then we are simply adding the constraints, all the constraints. Yeah. After this, we can actually take a look at the database. So this is the Airbnb database. We can take a look at the tables here. Just hit refresh. Here you can see we have all the tables. You can look at the ER diagram here for the whole thing. You can look at all the tables here, right? The foreign keys. Indexes are here. Yeah, all the indexes are here. We can also look at the ER diagram that got generated by this dbeaver. So you can play around with this. So this is the similar diagram that we had here, right? This kind of a diagram. This diagram is now here. So here you can see for app user, this user roles got generated. We didn't generate it. app user, this user role, right, this thing over here, this got generated automatically. So each user role will have user ID and the roles. Then we have guests connected to the app user, that is great. And this table, this is the connecting table, booking guest, right, we created this one. So all these things are getting generated. So now I think we are good to go. We can get started with everything. We can get started with the code now because our schema is ready, all the unique constraints are ready. We are yet to add indexes now because that part is still remaining. But indexes is something that you would keep on updating inside your coding journey as well. You create your database, you create your schema, but indexes are something that you update on the whenever your need arise. For example, you want to add a new feature that searches on something. For example, you want to search your inventory on the basis of search factor someday, then you would create an index basis on the search factor. So that's something that we will keep looking at our queries, and then we'll update all the indexes later on. But we have added all the unique constraints and all the foreign keys constraints and all these things, right? So that is all here working great. User is not here, it's called app user, because if I had tried to create a user, that would have resulted in an error. All right, you can try it on your own, you would see that you would be getting an error because user is something that they use internally. So that's why we have app user. And then we can also click on these things, and then we can see like how this booking is connected to everything. So click on this ER diagram, you would be able to see all the connections here. Click on this data, and then you will be able to see all the data. One thing I wanted to show you was the hotel. Inside the hotel you would see where are those fields? So these are named city, email, location only. Oh, I thought they would be named something else entirely. Yeah, so here you can see these are called city, email and location. I was under the impression that those would be named something else. As I mentioned earlier, right, I mentioned that they would be named hotel, like contact info, address, contact info, phone number, but that's not happening here. Oh, good for us, I guess. We can change it though if you want. We can update the join column here, so that would update the column information here, and that would update the column information. It's not happening here. Let's see, do we have something here? No, nothing. Do we have something here? Nothing. We cannot configure it anyway. Cool. So yeah, all these so you can see that this hotel contact info, this is not generated separately, and all these fields are here only, right? A good thing about this is now that if you want to use this hotel contact info, maybe name it something else, maybe name it contact info, because even a user can have address, phone number, email and location, right? So what you can do is you can use this embeddable in some other entity, right? This is now reusable, so you can reuse it anyway, and it's going to create columns like this. Good. You have inventory. Currently everything is empty, I know, but we are going to fill all these things later on with our APIs, and we'll put all the data, right? So this is it for today's class. Let me just look at the doubts if we have any inside the doubts chat. If you can put your doubts if you have. I'm just seeing two here. Can you explain briefly about generated value and type of strategy? So yeah, generated value actually auto generate things, auto generate the ID, and it's used to auto generate the ID. And you can see here when I put the generation type as identity, it has set it to generate default as identity like this, right? So there are multiple generation type. Actually generation type are identity or auto. If you set it to auto, that means you are letting your database decide which is best for it. All right, and then if you set it to auto in PostgreSQL database, it mostly goes to sequence only. Sequence, what does sequence do is that it's going to create another table for you inside the database. It's going to generate the ID by using the sequence table, right? Why is it useful? Why do you want to keep it as sequence? For example, in batch processing, what you have is you are doing a lot of batch operation on a particular database. So you want to keep track of the ID inside some table. right? Like at which ID am I right now inside my database. So for that you keep it as sequence, and that is useful when you are doing some batch processing operation. It's not useful when you know not doing any batch processing. And then you have this UUID. This is just a random UUID string that you can use. This table, I'm not really sure what is this table, but yeah, these are the most important ones. I generally keep these things as identity because you know simple and get started. So I hope this is making sense. Who asked this? Tariq, Muhammad Tariq. Muhammad Tariq says I need to create ID in 10 digits. How can I achieve? For that you have ID generators, right? So in here generated value, you can also create your own custom strategies, you know. So just learn about those things. I have not talked about these things, but I mean just take this question and ask on ChatGPT, and you will get an answer. You can generate your own create your own strategy, and then put that strategy here. It's going to generate an ID for you. So PostgreSQL is very versatile that way. How you make sure that you want to join to table this way, like say A to B and not B to A? See, I look at the table connection. I think I've mentioned this multiple times, but I'll do that here. For example, here, do I want to have allow my users to have the information about the guest? If I do want to do that, then I'll probably create another table. That would be a join table which will have user ID and the guest ID. In that case, I'll probably add the information about the guest inside the user table, and then my user table would be owning that join table. But here you can see inside this is a many to one relationship, right? And each of my guests can have the information about the user ID. So it makes more sense to put many to one relationship like this way, and then what happens is that each guest will have a user ID. So each guest will have a user ID. So we didn't have to create another table, right? Just for this join between user and guest. So that's how I decide. I hope that I'm making sense. Usually most of the time what happens is that for many to one relationship, I don't like to create another join table. For many to one relationship, I don't like to create another join table. Whoever has the many to one, I like to create a join column there only. For many to many, you have to create a join table, right? And then for one to many, usually what you do is that you have a one to many relationship, and then you connect it via mapped by, right? So what I can do is I can go to this user, and I can say that, hey user, if you want to get all the guests information, you can do that like this. So private set of guests, right? But then you'll have to do this one to many, and then mapped by user like this, right? Even if I do that, I'm not creating another join column or join table. Remember, there is not going to be any guest array, or there is not going to be any other table created for this join. Why? Because this guest is someone who's going to own this, because this guest has this join column. So this guest is going to own this relationship, and they will have this join column, and they will have this column here, user ID, right? And then I can easily do user.guests, and then it's going to generate a SQL query for me. The SQL query is very simple, as you can understand. It's going to go to the guest, select star from guest where user ID equals to the current user ID. So it's going to either way going to make a query call to this guest only. So just try to fiddle around with this, try to work with multiple scenarios and see what's happening inside the database. That way you would be able to learn much more. Probably what I'm saying right now is not making that much sense. Probably what you can do is just fiddle around with the database and see what happens when I put join table here, when I put join column here, I don't put join column there. Don't be afraid to try new things, otherwise you won't be able to learn new things. Any other question? I'm not seeing any question in the doubts, so I guess not. Let me just look at the chats. Another Postgres is a database, but dbeaver can be used to manage database. Yes. So dbeaver is basically just what do you call it? A tool that helps you to look at your databases or manage your databases. Analytics tool. Is dbeaver and Postgres are same? No. Postgres is a database. dbeaver is something that helps you look at that Postgres database. Right? You can take your Postgres database and you can put that database on EC2 instance, and then you have your database at a server, or you can use some managed services like RDS, and then you have your Postgres database in AWS managed service, right? So Postgres is just a code that manages your relational database, right? It's kind of like MySQL database. In dbeaver you can actually connect with multiple kinds of database. Yeah, you can just click on this and you will see that Postgres is just one of the database. You can easily connect to other databases like MySQL, probably connect to the Redis here as well somewhere, Flink, a lot of other things as well, Apache Hive, Athena, Spark, all these things, right? That the AirDynamo router gets generated in the Postgres. No, that is something that's happening via this dbeaver only, right? So that's a really great tool. With this, what you can do is actually, let me show you. Yeah, with this diagram you can also take a picture of this diagram here. There is a button, it's not clickable right now. I don't know what happened, but you click on this button and your image gets downloaded, if that image is very important to you. As I create and update, timestamps are being used in many entities. I used embedded here. So timestamps are going to get auto generated. You don't have to worry about those. I have not put the timestamps here inside my payment, so I'll do that now. Yeah, timestamps are going to get auto generated because we have added these annotations, right? Karan says, why are not we using JPQL or Spring Boot JDBC? We are not going to use JDBC, that is for sure, but JPQL is something that we are using, right? This is using JPA, and JPQL is something called query language based on Java Persistence API or Jakarta Persistent API. So JPQL will come later on when we create our APIs. Currently, this is JPA that we are using, which is Jakarta Persistence API. JPQL will come later in the coming lectures, but JDBC is something that we will not use because that's a very low level abstraction. All right, with that, how will I connect Postgres with DBV, sir? See, all these things I have mentioned in the week 3 lectures. So just go through the week 3 lectures. I have shown you how to install PostgreSQL. I have shown you how to install dbeaver. I have shown you how to connect your dbeaver with PostgreSQL. And also in the beginning of this lecture, I mentioned that briefly. So just walk through those things again. And if you have any more questions, simply ask me on the chat on our Discord. But I don't think we have any more questions about. Let me just check once again. Yeah, we don't. All right, guys. So with that, I'll see you in the next one. We have successfully added all the entities. Now we'll start with the API implementation from the next lectures. Bye bye. Take care. Good night.